Well, hello. We are going to discuss C++ pointers and arrays today. We are going to then we're going to do it in a kind of model it and then also look at it on a whiteboard. So I have a project here that we're going to be using for demonstration, and what I want to do mostly for this demonstration and video is kind of discuss what I call the three sides of pointers. So the three sides of pointers, because essentially pointers are kind of difficult to learn. So what I like to do for students is break down pointers to their simplest components, because the syntax and semantics, and what I mean by that is syntax is what you write, semantics is how you write it. The syntax and semantics of pointers can be quite difficult, but always, no matter what kind of syntax or weird syntax you're actually using to access the different parts of a pointer, the pointers always come down to three different attributes. The first attribute is the address of the pointer. Now, when I say the address of the pointer, I'm talking about the actual address of the pointer that's automatically assigned to a variable when it goes on the stack through your stack memory that gets given to you when your application starts. When your application starts and you declare something like integer I, that's actually going onto the stack as memory. It's 4 bytes on the stack, and you can access that with an address that's automatically assigned. So I'm going to be given kind of addresses. I'm going to be putting numbers to these variables and pointers. Just know that these addresses are actually being automatically assigned, it's just for demonstration purposes, the addresses themselves. But you can think of an address as being memory in RAM that's assigned to your application that you make use of, and you just declare a variable, and that memory is available to you, and that that variable goes into that address position and for the variable itself. So you just have to declare it, and it goes on the stack. A regular variable like integer I has two parts to it. The first part of a regular variable is the address of the variable, address of variable, and then the value of the variable. So let's look at what that actually looks like when you declare that variable. It automatically goes on the stack and it's assigned an address, and again, I'm just going to make it up. So let's consider this integer I, and then we'll get into the three sides of what a pointer is. An integer, regular variable on the on the stack, you can kind of think of it as kind of a box. And let me get my whiteboard going here. Helps to turn the power on. Think about like the integer I that we have in there. It's kind of like a box. You can think of it as a box, and in that box you have whoops, looks like I need to undo that. You have the location in RAM of that memory. So for an integer called I, what that means then is that there's 4 bytes. An integer is 4 bytes. So in RAM somewhere, let's say that this variable will be assigned the starting address of 3000. What that means then that between 3000 and 3004, that variable actually exists in memory, 4 bytes worth. So you could go to address 3000 and access that bit of memory because we know it's 4 bytes. So then we would assign that variable to a value, and let's say that we assign it to 5. So once we assign that to 5, what then happens is this line goes to the address that integer I has been declared on the stack, and essentially puts the value 5 inside of there. And now we have integer I address 3000 to 3004 with the value of 5. Do something with that. That's a horrible int. Okay, well, all right. So with that's the two characteristics of a regular variable. Now a pointer has three characteristics, or three sides to it. The first side is the address of the variable, or address of the pointer, because all pointers, no matter what they point to, are always 4 bytes. The other characteristic of a pointer is the address, or the value, or the address it points to or references. And then there's the third characteristic of pointer, the value of the address that it references. Okay, that's a mouthful. But here's the thing. Once you understand these three characteristics of a pointer, there's literally no other complication to the pointer other than looking at the syntax and semantics and deducing which of the three characteristics that syntax is referring to. Because pointers can get pretty deep in syntax and semantics on getting them to work within code and using these three characteristics. But no matter how difficult the code looks to kind of decode, as long as you remember these three characteristics, it always comes down to those three. It's never more complicated than that. Then you can always kind of muddle your way through. So let's look a little bit more into the address of the pointer. So what I'm going to do here is I'm going to declare a variable, or a pointer variable. And this is going to be a variable that we're going to have that points to an integer. So we're going to use the type integer, but then we're going to put the asterisk in here to denote this is a pointer. Okay, so what this does is it puts 4 bytes onto the stack, which a pointer is 4 bytes. So it's actually going to create an address for that pointer. And then what we want to do is when we declare a pointer, we always want to say that that pointer points nowhere. So we're saying that that pointer points nowhere to begin with. So let's look at what these two lines of code does. Line 8 is going to be... Oh, yeah, okay, I got to go back to the whiteboard here. Okay, so line 8, that's when we declare an integer. Well, let's actually go over here. An integer that is a pointer called pointer, an integer pointer, and you can think of that as a box too, just like your normal variable. So just like your normal variable, it's going to have an address that's 4 bytes that's assigned to it. Let's say it starts at 4000 and ends at address 4004 in your RAM. Okay, and then we're going to automatically assign that value to 0, saying that it points nowhere. So the first characteristic of a pointer is this one right here. That's characteristic number 1. The address of the pointer. This one you won't have much use for unless you're working with what we call a double pointer, which means that it's a reference to a reference. But we're not going to get into that. Forget I ever even said it for now. Okay, so this is the first characteristic of pointer, its address. Now the next characteristic of the pointer is the address it points to or references it. So when we did pointer is equal to 0, what we're doing is we're assigning the value of what that pointer holds. So what we did essentially is put the 0 right here, just like we assigned I to 5. So essentially we've created a pointer on the stack at a specific address that points nowhere. So this right here is characteristic 2. Okay, now for characteristic 3, we actually have to reference that pointer and make it point to an address of a variable to reference that variable. So what we would want to do is, let's say that we want to reference I over here. We would want I's address to be stored here on what the pointer references. So what we want to do is we want to assign that pointer to the address of I. And we do that with this line of code. We can say pointer is equal to, and you use the ampersand to get the address of a variable. So now we referenced and we said pointer is equal to address of I. So then what ends up happening now is that instead of 0 in there for this line, we've now assigned it to the address of I. So now it has the value 3000 in it. And it is set to reference and now point to this address. And that's the third characteristic of a pointer. So now we can use pointer in lieu of I. So if I were to do this, what this would do is output what pointer points to, or the address of I. If I were to do this, output the address of I. Okay, so since pointer's value holds the address of I right here, and we did that by assigning pointer to the address of I, we now have essentially the ability to reference I with pointer. If I were to output the value of pointer, it's going to be outputting the address of I. And if we look at our output, we'll see that they should match. Okay, so you know I'm using nice numbers. This is in hexadecimal, so you can actually look at the decimal memory value that's been assigned to I if you put that into your calculator under programming mode. So what this is, these values are the same, which is totally expected because pointer is pointing to the address of I. And what we could do then is we could do different things like say, okay, cout pointer. Now this is where syntax and semantics gets really weird, because what we want to do is we want to reference the third characteristic of the pointer here, which is the value of the address that it references. So what we have to do is what's called dereferencing. We have to say, okay, I don't want you to output the address of I or what the pointer points to. I want you to print the value of what the pointer points to, and it's called dereferencing. And you put the asterisk in front of it. Now this asterisk here on line 8, the asterisk use here, and I'm talking semantics, how you write it, is totally different and a separate thing than the use of this asterisk. This is declaring a pointer. This is dereferencing a pointer. And notice that there's no int in front of it or anything. So this is what we're referring to wanting to print the third aspect of a pointer. So when we output asterisk pointer here, since pointer points to I and we're dereferencing it, it's going to print the value of what the pointer points to. And it looks like I skipped a step here because we didn't give the value anything. So this will actually probably make some sense. We're assigning I to 5. Yeah, okay, so I is assigned 5. Okay, now we are ready to output what the pointer points to with the dereference. And since I is 5, when we output the dereference pointer, we're going to get the value 5. Okay, I guess I lied. Oh, yeah, well, duh. I set I to 0 here. Okay. Okay, so there we have our code and our output. We're outputting the address of I and what the pointer points to, which is the address of I. And then we're printing out the third aspect of a pointer, which is the value of the address that it references. So now we can actually use that to manipulate I. So I can say, okay, go to the value of what the pointer points to and assign it to 2. And now, after this, when I do a cout of I, since I'm assigning the value of what the pointer points to 2, what I'm doing is essentially, okay, go through our pointer reference, take our pointer reference, and go through what it points to, and change the value from 5 to 2. So now when I output I, it is now the value of 2. So pointers always, no matter what syntax and semantics you're working with, always have these 3 characteristics, and that's it, nothing more. They're no more complicated than these 3 aspects. Once you understand these 3 aspects, then you can decode or understand a little bit more what's going on with the syntax and semantics and break it down for any kind of weird double pointer, reference of pointer, all kinds of weird syntax and semantics you'll see out there. Okay, so let's run this. All right, so we have our output now. We got 2 here instead of 5 because we used the reference or the pointer to change the value of I. Okay, so once you know this and you understand those 3 characteristics, then now you're ready to work with pointers. So let's get a practical example of pointers and where they're used, and that's in the use of arrays. So what we're going to do is we're going to transition into pointers and arrays. And essentially, an array is just a pointer to a contiguous, or a pointer is just an array, or an array is a pointer, excuse me, that points to the first byte in a contiguous block of memory. So let's say that we're going to have an array, an integer array of size 2. And I declare a pointer, I pointer, or just pointer. I'm going to assign it to 0, but then what I'm going to do is I'm going to say pointer is equal to I array. Okay. Now, before we do that, let's do this. Let's say I array of 0 equals 1. I array of 2 equals 2. Okay, so let's go to the whiteboard and look at what's going on behind the scenes, and then we're going to add some more to this. Okay, so let's go ahead and clear this. Okay, so we have I array, which is a pointer. Just know that an array is a pointer. Okay, and what it is it's a box, just like the other ones. And it's got the 3 characteristics of a pointer. It's going to store an address right here in the top, and it's going to have its own address. Let's see, it's at address 3000. And then what happens is when that array is created, you have a contiguous block of memory that represents that array. Yeah, for some reason, this thing is being a stinker. Okay, hopefully I can get it so, okay, there we go. All right, so that contiguous block of memory, what it means by contiguous block of memory is it just basically means in order. Try to get this pen so it's not being a stinker anymore. Looks like. Okay, you know what? I'm going to draw this out and then I'm going to pause it and then come back. So I got a good drawing now. Okay, so an array itself is just a pointer that stores the first byte of memory in a contiguous block of variables. So essentially, an array, how an array is done in memory is you only need to have the address referenced of the first block of memory. And then after that, it knows it's an integer array, and the next element in the array is just 4 bytes more. So it's contiguous, meaning they literally put the memory in order. So all you need is the first byte stored of that whole block of memory. Because we could have a third one out here if we want with a 3-element array. And this one would be at address 1008. And remember, I'm just making these numbers up. These are automatically assigned. So since we know that this is an integer array, and integers are 4 bytes each, that means that our array of 2 is created within 8 blocks that are in order. And so that means you only need the byte the byte number of the first block, or the starting byte number of the first block of the array. And then that's what the main name iArray references. It's just a pointer that points or references the first block or the first byte of a contiguous block of memory that represents the elements themselves in the array. So we are only doing a 2-element array, so this is not there. And then we assign the values 1 and 2. So the pointer iArray holds the value 1000. That is the byte of the first set of 4 bytes in this contiguous block of memory that represents the actual array. So you reference the first starting point of that contiguous block of memory that represents your array. So we can actually now use or set up a variable called pointer that we are going to assign to the value iArray. So let's look at that real quick. Look at that line. Okay, so this line right here, line 13, I'm saying, okay, pointer, what is stored in iArray? I now want pointer to store. And since iArray itself is storing the address of the pointer, what then happens is the value inside of iArray is now put down here. Now this pointer is a whole nother pointer that exists in a whole different address. And it's 4 bytes. So now the pointer references your block of array elements. And so now you can use pointer interchangeably with iArray. For instance, I'm setting pointer of element 0 to 4. And this is an R value of the pointer, and I'm telling it, and that what I mean by R value, we're using the right-hand side of the pointer, and I'm telling it to assign the value 4 to address 0, or to the subscript 0 in the contiguous block of memory. So then what happens is, since pointer is pointing to this block, essentially that means I want to assign this to value 4, and it's no longer going to be 1. And then when I output iArray of 0, it's going to go to the same block of memory and output the value that's inside of it. So we're essentially using pointer as just another variable to reference the same block of memory that represents your array. And this would be your R value. Or right-hand side because we're using the subscripts. I'll be talking about L values shortly. It's the left-hand side of pointers. Okay, so this is going to then output 4. Oh, looks like I've got a problem. Oh, duh. Look at that, 2. That should be 1, guys. Yeah, okay. So, all right, so this should be 4 now that I fixed that. Okay, so you see we got the value 4 here for our output on line 15. So we used pointer after we assigned them to pointing to the same place. We used pointer in lieu of IRA, but they're actually referencing the same thing. So this is using the right-hand side of the pointer. Now let's do it with the left-hand side of the pointer. And what I can do is I can say, okay, Mr. Pointer, now that you're pointing to IRA, which has the values 1 and 2 in it because I took out that equals 4 statement, what I want to do is, let's say we're going to use an L value to assign the value. And what you would do is you would say, I want to go to what the pointer is pointing to, which is the first element cout dereference pointer, and we're using that third characteristic, go to the value of what the pointer points to. Since the pointer points to address 1000, and remember let's go ahead and make that 4 just for the sake of being consistent with our drawing. There we go. And what we're doing is we're saying, okay, Mr. Pointer, dereference it and give me the value of what you're pointing to. And since the pointer is pointing to address 1000 and the value at address 1000 is 4, that's going to output 4. So we're going to output 4 here for line 14. And there's our output 4. So that's using an L value to print what the pointer points to. Now we could do what's called pointer arithmetic, and this gets really kind of weird. We can say, okay, pointer, I know you're 4 bytes. I want you to point to the next one. So we do a pointer plus plus. And now when I do a cout, and this is all using L values, we're working with the left-hand side of the pointer. The actual way it's was built first before they introduced subscripts. And now when I output pointer, or what the pointer points to, it's going to be pointing or printing the value 2. Did I put 2 over here in our little thing? Yeah, 4 and then 2. So I said, okay, pointer, line 15, what it did is it said, okay, pointer, don't point to address 1000, increment up 4 bytes and point to address 1004. That's line 15. And now that pointer will point there. So now pointer is going to hold the address 1004 because of pointer arithmetic. It's going to be in your book. Read it. It's not super important that you you've got a basic understanding that we're covering here today. That's important. But pointer arithmetic is not something you'll be using on a day-to-day basis. So now when I output pointer using the L value, it's going to give me the value 2 because I told the pointer to increment and now point to the next block of contiguous memory that's 4 bytes because it knows that it's an integer pointer. So now when I dereference that pointer, it's going to output the value 2. Okay, so we had the value 4 and then 2. Okay, so that's kind of pointers in a nutshell and how they are associated to arrays. Now what you can do is you can actually use the pointer in all L values and get rid of the subscript and using R values, right hand side. The reason why we call it right hand side is because we're using the subscript on the right versus when we use when we do something like cout asterisk pointer, that's using the left side syntax and semantics, and that's why we call this an L value. All right, so instead of using an array for your pointer, what the heck with it? Let's use hard coding a static array. Let's use a pointer for our array, and let's ask for the memory from the operating system, and say, hey, I want a new array, and it's going to be what we call a dynamic array for dynamic memory. So that's going to change us a little bit over here. Okay, so first we create the pointer. That is line 8. Then, and a box is created and we're put on the stack. That 4 bytes that represents your pointer is put on the stack. It's automatically assigned a starting value, and it exists within 4 bytes. And we assign it the automatic value of it pointing nowhere. Okay, so then we say, okay, operating system, I want some memory for this pointer. So we say, okay, operating system, I want you to find me 3 integers. And I want you to give me the address of the starting block of that contiguous block of memory and store it in the reference called pointer. So the operating system then goes out to the stack, or no, to the heap, because the stack is your automatic memory assigned to you, and the heap is the rest of the memory available to you. And this is how you do dynamic memory. So you say, okay, operating system says, okay, I'm going to find you 3 contiguous blocks of integers that are all together, that no operating or no other process is using. And I'm going to give you the first byte that represents that block of memory. Okay, so here's the 3 that are going to be created. Some of them got some bad proportions here. Okay, so let's say that the first block is address 10. The next one will be address 14. And the next one will be address 18. Okay, so then what happens is, as soon as the operating system finds those 3 contiguous blocks of memory from the heap, all the rest of your memory available in RAM, it will then assign the address 10 to what the pointer points to, and now that pointer points to that block of memory, and we can use it in terms of L value. We can use it to access these elements with L values in pointer arithmetic, or R values in our subscript operator. But the thing is that memory off the heap, we got to actually free. So we got to tell it to free this memory so that another system can access that memory, or you have what we call a memory leak. But let's use that memory first. So I'm going to say, okay, pointer. Okay, so then what we do is we fill up this memory with the values using our values or your subscript, we put the values 1, 2, and 3 in here. And that's what lines 10, 11, and 12 do. Now we can, of course, output those with the cout and look at that. And I encourage you to do that. But what I want to demonstrate then is, let's print it with a loop. Okay, and then here's our last step. We must free the memory. So you got to use the delete, and you got to send it your pointer. And what ends up happening is when you do the delete, you're telling the operating system, okay, operating system, I'm done with address 10. You say delete pointer, pointer holds address 10. You say, okay, operating system, I'm done with address 10. And the operating system knows to go up and free this memory up for another process to use. And that's what line 19 does. But that's after we've used it. So let's go ahead and look at our output. And we got 1, 2, 3. Okay. Now this gets really screwy weird, but I'm going to give you a glimpse of what a double pointer is. Let's say we wanted a position of a two arrays. Let's say that we have something like this, or two-dimensional array. Array of 2 by 2. Okay, so the way a dimension or way a double dimension is done, and you can do it with the new statements and create a double dimension or a dual dimension array using the new operator. But I just want to use iArray as a model and give you an understanding, because what iArray is actually is what we call a double pointer. It's a reference that points to a reference. So we would, if we're using an L value for this double pointer, we would be assigning it to iArray. And the double pointer syntax is specific. Because essentially what you do when you want a multi-dimensional array is you have a pointer that points to an array of pointers. And that's how iArray is done. So I'm going to give you just a quick little drawing here, just so you understand the next step in how this is done, and to give you an example of what a double pointer is. So we have a double pointer called iArray. Now I'm using our values over here on line 7. To use an L value, you would declare it something like this. And I've got an error for some reason, but it doesn't matter. So line 10 would be using an L value to create a two-dimensional array. So I'm using an R value just because the syntax and semantics is a little bit of a pain when you're using L values for a two-dimensional array. Which reminds me, interesting. Okay, let's just comment that out. Let me draw it out for you so we have an idea of what a double pointer is. It's just essentially it's a reference to a reference. And a double pointer can be used by passing to functions, or it could be used to reference a multi-dimensional array. So you have your double pointer, which is a reference to a reference, and that's iArray. Oops. Whoops. Something happened there. Okay. That's this guy. Sometimes this thing just kind of does weird stuff. Okay. So iArray is going to be this guy. That's our double pointer. And let's say that it starts out at address 2000. And what it's going to do is it's going to hold, if we're doing a 2x2 array, it's going to hold an array of single pointers. Okay, so this will be 3000. This will be 3004. And let's say we had the values 1 and 2 in there. And since this is our first reference, oh wait, no, we don't have the values 1 and 2 in there. Never mind. That's going to be, I'm getting ahead of myself. Okay, so this guy, this double pointer is going to point to address 3000. And these guys are actually going to be pointers. And what they will do is the double pointer references the first reference that points to an array of pointers that then will reference the starting point of the actual integers, which is a 2 by 2 array. So you're going to have the actual integers here. Okay, so this first pointer is going to reference the address of this first variable. Let's say that it's at 1000. So it's going to hold 1000 and point here. So this is your first dimension, dimension 0, dimension 1. The first point, the double pointer points to the array of references. This dimension element 0 will point to the actual variables that exist down here at address 1000. And the next one will be, let's actually do something over here. Let me change this a little bit. This will be 1000, oops, okay, 1004. This will be 1000. And so this guy will point to here, which will be our 1, 2. So this will be element 0. So this will be 0, the first 0, and 0. That will be this element. Okay, so this is your first dimension. This is your second dimension. So you go to position 0, and at position 0, you go to position 0. Okay, this is, guys, is position 0, 1. Go to position 0 and the second item in there. So this position 0 just holds the address of this block of 2 actual integers, 1000 and 1004. Okay, now your dimension 1 will reference this block. And let's say that these guys are at address 200 and 204. And let's say that this is going to be having the value 3 and 4. So this would be position 1, 0, and 1, 1. And address 200 would be stored in this guy. Okay, so the double pointer points, because a double pointer by definition is a reference to a reference, or a reference that references a reference. So this reference is going to refer to the first block of memory, oh my goodness, which is address 3000. So it's going to reference your array of pointers, and each of those pointers will reference the first byte of an actual block of integers, 1000 and 1004. And then your next one, and the double point or the single pointer, will reference the next block of values. So when you use array of 0 and 1, when you use this in syntax, when it says go to the 0th element, use array, go to the 0th element, and from the 0th element, that reference, go to its array and access this value. And that's how multiple dimensions work. Now, let's talk about triple pointers. That's 3000 3 dimensions. Okay, triple pointers do exist. Quadruple pointers. What do you call 5 pointers? So basically a triple pointer would be a reference to a reference to a reference. So you just take this whole idea and extend it into this monstrosity right here. Okay, you know a practical use of double pointers. You understand how arrays relate to pointers. I talked about L values and R values. I think that was my goal for this particular video. You know how arrays and you got a better understanding of pointers. And remember, even if it's a double pointer or some weird wacky syntax or semantics, there's only three attributes to a pointer. It always breaks down to those 3. All right, thank you.